In algebra, we often have to simplify an expression or equation, and simplifying often has to do with combining like terms. So what are like terms? Like terms are any terms that have everything the same except for the number in the front. So if we have, let's say we have 3x and 3x squared. These have the same letter, but the exponents are different, so these would not be like terms. However, if we have 3x and let's say we have 8x squared plus 3x squared, these are now like terms because they have the same letters with the same exponents, and the only thing they differ by is the numbers in the front. So in this case, we can actually add them, and we will have 11x squared. Also, if we have, let's say we have different letters, such as 2xy plus 3x plus y plus xy. Of all of these different terms, the only things that have the same combination of letters is the first and the last. So we can add them, and we will have 2 and 1, which makes 3xy plus 3x plus y, and so on. The exponents also work with the roots. So sometimes we may get an example such as square root of x plus 2 square roots of x minus cube root of x. Well, the first two are the same, but the last is different, so we can combine the first two, but not the last. And that would be 1 square root plus 2 square roots makes 3 square roots of x minus cube root of x. So when we combine like terms, when we work with expressions and we simplify, we often follow the same order. That order is the order of operations, and the order of operations is parentheses. Here it is. Let me scroll a little bit. So here's the order of operations. We start at the top, and if we can do it, we perform the operation. If we cannot do it, then we skip over. So the first thing to do is we simplify everything inside the parentheses, then we do exponents, then we can do multiplication or division in any order, then we can do addition or subtraction. Once we go all the way from the top to the bottom, we will have our expression as simple as possible. To remember this procedure, we can remember the phrase, "Please excuse my dear Aunt Sally," which, as you notice, has the same first letters. P stands for parentheses, E for exponents, M multiplication, and so on. So remembering the phrase, "Please excuse my dear Aunt Sally," we can recall the operations parentheses, exponents, multiplication, division, addition, subtraction. So let's look at a few examples and how to do this order of operations to simplify and any expression. So below are some examples. I'm going to zoom in and look at all of them at once, and then we will start. So here are some examples. There is 7 of them, and in this video let's look at the first 4. 1, 2, 3, 4, and then in the next video let's consider the last 3. So here is the first 4 examples following the order of operations. Now there are no parentheses, there are no exponents, there is no multiplication, no division. So the first example only deals with addition and subtraction. So we're looking for anything that is like that we can add or subtract. And we notice that there are 2 terms that have x in them, so these would be like terms. 3x plus 2x will make 5x. So 3 plus 2 makes 5, and we are counting x's, so we have 5x. Then the numbers are always the same. If we take 5 minus 7, that is always the same. To help us remember how to do the subtraction, we can think of money. If we go to the bank and we have $5 and we withdraw 7, our balance will be negative. We withdrew more than what we had. So 5 minus 7 is minus 2. And this is the final answer to the first example. Now let's look at the next example. Here we have x's, but they have different exponents. When they have the same powers, these are like terms. But the x squared and the x, these are not like terms. So let's simplify and combine the like terms. When there is no number in the front, that means 1. So we have 1x squared plus 2x squared. 1 plus 2 makes 3, so we have 3x squared. Notice that the power does not change because we're not multiplying, we're simply counting how many of the x squared do we have. And the first term says that we have 1x squared, and this term says that we have 2x squared. Literally, it means x squared plus x squared. So we're counting how many of the x squared we have. 1, 2, 3. So 3x squared, that's what that answer means. Then we have, let's look at the other terms. Here we have negative 5x and minus x. Again, if there is no number, that's a 1. So we have negative 5 minus 1, and that makes negative 6x. Green a little bit difficult to see, so let's change it to something else. Let's call it negative 6x in purple. And then finally the numbers. 3 plus 4 will make 7, so plus 7, and that's the final answer to our example number 2. Next example, we have different letters. The x, y together is considered one term. So this is one term, 2xy, and this 3xy is exactly the same term. So we can combine these two, but not the 2xy with the x, and not the xy with the y, even though they both have x and y, but it has to be exactly the same combination with exactly the same exponents. So of all of these 5 terms, the first and the fourth, these are like, and then the y's with the y's, these are like. So let's combine them and see what we get. 2xy plus 3xy will make 5xy. The 3x is by itself, there is nothing to combine it with, so that stays. And then 1y minus 2y will make minus 1y. And that's the answer to the third example. The last example, we have square roots. If there is no number in the root, then it's a square. So we have 2 square root of x plus 3 square root of x minus 5x, just regular x, no square root. So this 5x is different from the first 2 terms, and we cannot combine them. But we can combine the first 2. So 2 square root of x means 2 times square root of x, and that's 3 times square root of x. So we are counting square roots of x. And 2 plus 3 makes 5 square root of x minus 5x, and that's the end for the example number 4. Now, in the next video, we will look at the other 3 examples. If you have any questions on anything or have any other examples you would like me to consider, please let me know. I'm looking forward to hearing from you. Thank you so much for your time. Take care.